What is force? Vocabulary: force, Newton, net force. Objective: students will be able to describe what a force is, describe how balanced and unbalanced forces are related to an object's motion. Force to change. Misconception: any object that is set in motion will slow down on its own. Actually, a force is needed to change an object's state of motion. Like if it was at rest, to stop it; if it was in motion, if it was at rest, to let it move; if it was in motion, to stop it, and so on. A soccer ball sits at rest. You come along and kick it, sending it flying across the field. It eventually slows to a stop. You applied a force to start it moving, and then it stopped all on its own, right? You think so? This is not right. Forces cause all changes in motion. Just as you applied a force to the ball to speed it up from rest, the ground applied a force to slow it down to stop. So we are going to talk about this force in the next lesson, which is the friction force that is applied by the ground on the object sliding along it, and how this force affects the motion. So now the ground did not apply a force to the ball, it would keep rolling forever without slowing down or stopping. If you roll a ball down a hill, will the ball eventually stop on its own? No, friction between the ball and the hill will cause the ball to slow and stop. So how are forces described? As a definition, a force is a push or pull exerted by one object on another object. Okay, as you can see here, example 1, pressing on a computer key is pushing it. Example 2, moving a chair away from the table, this is pulling it. And above here you have a diagram or a figure showing what do we mean by push and pull. Push means applying a force away. Pulling means applying it towards you. Vector quantities. Prerequisite. Quantities that are described by both magnitude and the direction are vector quantities. Example: velocity, acceleration, and the forces. So we discussed velocity and acceleration in the previous lessons. Now we're going to talk about the forces. Like velocity and acceleration, a force is described by its length and by the direction in which it acts. A force vector for sure. Okay, a force vector is described by the length and the direction. A force is described by the magnitude and the direction. So are the two forces exerted by the two men on the box equal forces? No, the two forces are applied in different directions. So one of the forces is exerted to the right while the other is exerted to the left. So as vectors, these vectors are not equal as forces. These forces are not equal because they are applied in different directions. So representation of a force is represented by a vector. The length of the vector represents the magnitude of the force. And the magnitude of the force is its strength. So it's measured in the SI unit called the Newton, after the scientist Sir Isaac Newton, who was the first one to talk about the forces and so on. And we have the arrow here points in the direction of the force. Application 1. Two forces F1 vector and F2 vector are exerted on the girl and the wagon respectively. The forces are represented to a scale of 1 cm to Newton. Determine the direction and the magnitude of each force, knowing that the length of F1 vector is 2 cm and that of F2 is 4 cm. So F1 vector is direction, its direction is to the right, and its magnitude, we multiply the length of the vector by the given scale. So 2 Newton per centimeter is the scale times 2 centimeter, the length of the vector, equal 4 in Newton. Centimeter and centimeter cancels here. Similarly for F2 vector, it's directed to the right. So the magnitude is the scale times the length. Centimeter cancels, this is 8 in Newton. How do forces affect the motion? Often more than one force acts on an object at the same time. So it's not necessary that only one force acts on an object. So in order to study the effect of all these forces together on this object, we have to combine them. We have to find the net force. So the combination of all the forces on an object is called the net force. The net force determines if and how an object will accelerate or move. The net force vector is the sum of all the force vectors acting on the same object. So for your level, we're going to consider a simple case in which the forces are collinear. So when the forces are collinear, what do I mean by collinear? like all are horizontal, or all are vertical, all are oblique, making the same angle with the horizontal. So considering this simple case, we need also to go into further classification, or considering different cases. So we have case 1. When combining forces that act on an object in the same direction, the magnitude of the net force is found by adding their magnitudes. So the resultant vector points in the same direction of the component vectors. However, in case 2, when combining forces that act on an object and they are collinear but acting in opposite directions, the magnitude of the net force will be equal to the difference, not the sum. So we have to subtract the smaller from the larger one, and the resultant vector points in the same direction of the stronger force. So we're going now to do direct application. We have this application too on the first case, in which both vectors are collinear and directed in the same direction. Like here, 3 Newton and 5 Newton both are horizontal and to the right. So the net force will be horizontal and to the right, and its magnitude is the sum of their magnitudes, so it's 80 Newton. Example 2, 2 Newton and 1 Newton both are vertically upwards, and the net force will be also vertically upward. Its magnitude equal 3 plus 1, which is 2 plus 1, which is 3 Newton. Example 3, we have two oblique forces making 30 degrees with the horizontal. So the net force will also be oblique, making 30 degrees with the horizontal, and its magnitude will be equal to 60 plus 8, which is 14 Newton. Now the other case, here, when they are collinear but in opposite directions, and here both are horizontal, the net force will be horizontal but in the direction of the stronger one. So the stronger here, 5 Newton, is greater than 3, so the net force will be to the left, just like the 5 Newton. Okay, and its magnitude is 5 minus 3, which is 2 Newton. Now example 2, both are vertical, but one is upward and one is downwards. The upward one is greater, so the net force will be upward, and its magnitude will be equal to 2 minus 1, which is 1 Newton. Similarly, here we have oblique making 30 degrees. One is to the upwards, one is downwards, so we have to subtract them, and its magnitude will be equal to 8 minus 6, equal to Newton, with direction in the direction of the stronger one, which is 18 Newton. So how do forces affect motion? Case 1, if the net force is 0, the state of motion of the object doesn't change. So the forces are said to be balanced. So if it was at rest before exerting the forces, whose sum is 0, the object will remain at rest. So if you have an object that was initially at rest, and for example, two balanced forces are applied on it, so such that the net force is 0, it will remain at rest. Or if it was moving in a certain direction at a certain velocity, and also the sum of all the forces acting on it is 0, so it will keep moving at the same velocity. However, in case 2, if the net force is not 0, the state of motion of the object changes. So maybe if it was at rest, it moves, or maybe if it was moving, it stops. So the forces here are said to be unbalanced. Application, we have two forces here acting on this box, exerted by two dots. Both here are like to the right, horizontal to the right. So the net force is equal to the sum of the magnitudes. 16 plus 10 is 26 Newton in the same direction. The box moves to the right, and the other one here we have opposite forces, 20, 10. So 20 minus 10 is 10 in Newton, and it will move in the direction of the greater force. The box moves to the right at the smaller acceleration, okay, because now the net force is less than the net force before. So though the net force in case A and B have the same direction to the right, but because in A the magnitude of the net force is 26 greater than 10 in Newton, so in A the object will move at a greater acceleration. However, in C the net force is 0 Newton, because both dogs are exerting forces on the box with the same magnitude but opposite directions. So we have 10 minus 10, 0 Newton. The box doesn't move, it remains at rest. Application 5, also we have, you push on a desk with a force of 120 Newton, and your friend pushes to the left, you push to the right and your friend to the left. So you push stronger than your friend, the object will move to the right, and the net force is equal to the difference between them. It's 120 Newton minus 19 Newton, so this is 13 Newton. However, now if your friend increases her force by 30, so it becomes 90 plus 30, 120 newtons. So now both of you are pushing in the same with the same magnitude. So 120 minus 120 is 0 newton. When the net force is 0 newton, the object doesn't move, it won't accelerate. And this application is also similar. We have two forces acting on the leash, 60 newton to the left, 12 newton to the right. So the net force is 12 minus 6 is 60 newton, and the net force will be to the right in the direction of the stronger force. Now predict if you pull one end of the skateboard with a force of 10 newton while your partner pulls on the other end with a force of 10 newton. Would the skateboard move? No, it won't. However, now if one pulls with 3 newton and the other with 6 newton in opposite directions, so the skateboard will move toward my partner who is exerting a greater force, which is 6 newton. Generalization: an object at rest pulled in opposite direction by equal forces will not move. An object at rest pulled in opposite directions by unequal forces will move in the direction of the greater pulling force. And this Venn diagram, we had these expressions outside the Venn diagram and we assorted them. These are common, so all forces are considered to be a push or pull, and all forces have directions. Now, unbalanced forces change an object's motion. However, balanced forces do not change an object's motion. Unbalanced forces means the net force does not equal to 0 newton. Balanced forces means the net force is equal to 0 newton. Vocabulary: newton as a unit for force. Force is a push or pull. Balanced forces, sum of all forces. Balanced forces will not change an object's motion. Unbalanced forces can change an object's motion. When net force is the sum of all the forces acting on an object. And true and false here: balanced forces do not change the motion of an object. This is true. Forces cause some changes in motion. This is false. Forces cause all changes in motion. A net force causes no change in an object's motion. It depends if it was equal to 0 or not. If Manuel exerts a force of 10 newton to push a desk to the right, at the same time Lean exerts a force of 15 newton to push the desk to the left, will the desk move to the left? Yes, it will move to the left in the direction of the force exerted by Lean, which is the greater force. And here you have to fill in the blanks.